Hi friends, Naji here. Welcome to my YouTube channel. So we are continuing our discussion with Langchain retrievers, and in this video we will be discussing on contextual compression. So what happens when we do the vanilla retriever? So it will actually run a query against the knowledge base and it will return few documents that matches with our query, right? And this will be passed to our LLM model, and that LLM model will generate the query or generate the answer based on the input query. So what happens is that whenever we return this document, it actually contains a lot of irrelevant data. So all these irrelevant data we will be passing to the LLM model. Then it will actually impact the quality of the LLM model, and LLM model sometimes it may happen to it will overcome the contextual limit of the LLM models. For that, there is another method that is Langchain has introduced, that is a contextual compression, in which it will actually compress after getting the value from the retriever or document from the retriever, it will compress the document based on the input query. Then only the compressed details will be passed to the LLM model. So this will actually bring the quality result or quality output. Okay, so we'll see how can we implement the contextual compression. Then one thing is that whenever we use the contextual compression, we have to ensure that we use the high quality LLM models, otherwise we will not get the expected result. Okay, so these are the few LLM models. Okay, these are the few sample code. So this is what we have discussed already. So what I have done, I am using a Ollama, and this is the model name we are using, and I have created a Ollama model, and I have created a Ollama embeddings, and here we are actually loading the document, splitting the document, then we are creating a FAISS retriever. Okay, then I am invoking the query. So let me have a query here. Maybe I can mention. I can define a query. Now I can pass the query here. So this is my query, and we'll see how can we implement the contextual compression retriever. For that, so let me complete this. For that, what we can do, first we can do the import. So see, these are the doc that is returned from the returned from the using vanilla retriever. So now let me import Langchain dot retrievers. Okay, here we can import the contextual compression retriever. So contextual compression retriever need two parameters. One is the compression model and other one is the base retriever. For the compression, what we are currently using is that we are going to use document compressor. Let me import LLMChainExtractor, and let me see. First we can try with the Llama, then we maybe, like, if that is not working properly, we can try with the OpenAI. Okay, and we have already discussed about LLM. Now I can define a compressor with the LLMChainExtractor dot from LLM. We will be using the Ollama LLM. We have our compressors ready. Now we can have our compression retriever. As I mentioned, compression retriever will accept, not contextual compression retriever, that will actually accept a base compressor, that will be the compressor, and it will be accepting a base retriever, which will be our retriever. Okay, so the retriever is defined here. The FAISS retriever is that we are using. Okay, so we are ready with our compression retriever. Now let me take the compressor doc. Here I can use the compression retriever dot. Okay, I can invoke and I can pass the query. Let me see. So this is the execution is in progress. So we are expecting a compressed document. We'll see. Okay, so here are the extractor relevant part. One of the nation's top mines, Justice Fair, thank you for the service. And if you travel 20 miles, so this result are not good because we are actually using very low model. I mean Llama, I think 7 billion parameter that we are using. So let me change the LLM. Okay, for that I can use OpenAI LLM, Langchain, OpenAI. Okay, I can import OpenAI. Okay, and here I can have a LLM OpenAI. I can use maybe OpenAI. I can set the temperature as 0. So let me pass LLM OpenAI here. Okay, now we can see what is the compressed doc. So it's working. Okay, see, in this case when we change the model from Ollama to OpenAI, we are getting a compressed result. What it says is, let me 0 dot page content. It says I did that 4 days ago when I nominated Circuit Court of Appeal Judge Kitani Brown Jackson. So it is somehow retrieving the data with a compressed form. So this is very useful when you have a lot of data and chunk size is too big. We will be able to do the compression part. So that is how the compression retriever works. And along with this, this will show you like one more method. This is not the compression, but this is actually a re-ranker. We'll call the FlashReranker. Okay. So what happened with the FlashReranker? So whenever we get a retriever, I mean we get the document from the retriever, what actually we does is we actually doing some kind of a re-ranking with respect to those document based on the query. Okay, so based on that some of the document will get high priority, and based on that it will pass to the LLM, so LLM will able to generate more accurate result. So this is the one method, that is a FlashReranker, and there is another re-ranker is available, that is a coherent re-ranker. So in this video we will be discussing on the FlashReranker. So this both are work in a similar pattern. That's why I thought of doing it in the same video. Okay, so we'll see how can we do the FlashReranker. For that, first what you guys have to do, first you guys have to install the re-ranker. Go to the requirement.txt file. I have already installed the FlashRank package. So please ensure that you guys have installed that. Now we can do the import part. So let me have a Langchain dot retrievers dot document compressor, retrievers dot document compressors, import FlashRerank. So we'll use the OpenAI also. We'll see how the re-ranking and the compression will work together. So here I will set a compressor. FlashRerank compressor is that we are going to use. I can have a compression retriever. Here we can have a contextual compression retriever. Here the compressor will be, the compressor retriever will be the compressor, the re-ranker compressor, and the base retriever will be the retriever. Now we can, okay, something is not correct, we'll see. Base retriever has some issue. Okay, this is not the, this will be base contextual compression retriever, this will be base. Okay, so this will be, okay, sorry. So this actually will be the base, compressor will be the compressor, and this will be base retriever, this will be our retriever, our FAISS retriever. Okay, now we have done with the re-ranker. I can have a re-rank document. We'll see how the re-ranking compression will happen. I can have a compression retriever dot invoke. I can pass the query here. We'll see. Re-rank the document. Here we can see the re-ranking is happened. So when we look on the re-rank document, we can see that okay, it says page content tonight. I call the Santa 2, and in the second document it's called and my report, and third it will call the and I will keep doing everything. So we'll see how the base retriever is working with respect to the query. Let me invoke with the query. Okay, so when we compare these two, the base retriever and the re-rank retriever, we can see the first content is right, that is tonight, and the second content is different. Okay, second content is like and my report. So when we do the re-ranking, flash re-ranking, the last one in the vanilla retriever is got promoted to the second. Okay, and the third one is and my report, and here we don't, yeah, that is called a second one, and I will keep doing everything, and I will keep doing, that is in the third position, and it has actually removed the second one from the compressed list. Okay, so this is how the flash re-ranking is working. Okay, so let me say what we have done. So we are trying to implement the contextual compression, which will help us to do compress the document that is returned from the retriever, and we learn two things. One is compressing the document using what we have used the LLMChainExtractor. Using that we have compressed the document, and another method that we have discussed, the flash re-ranker, which will actually re-rank or prioritize the result or document that is returned from the base retriever or vanilla retriever. Okay, so yep, that is all about in this video. Please do like and subscribe. Have a nice day. Bye bye.